So in the following set of notes, in 1 or 2 videos from now, we're going to talk about sort of a review of graphing polar graphs, graphing polar equations. But for the time being, let's talk about converting these either into or from polar form. So we'll talk about these ones first, convert the following equations to polar form. So we have y equals 4, and we're going to say, okay, well, y is equal to r sine theta. So 4 is equal to r sine theta. And if we rearrange that to solve for r, we get r equals either 4 over the sine of theta, or we could call that 4 times cosecant theta. When we see this one, this is in rectangular form now. Hopefully we recognize this as just being a circle, and it has a radius of 5. So in polar coordinates, or in polar form, this would just be r equals 5. Right. We could also, if we didn't recognize this, we can show that that's the case. X is r cosine theta, so if we square that, and y is r sine theta, so we square that, equals 25. Here we have r squared cosine squared theta plus r squared sine squared theta equals 25. Now we can factor out the r squared, and what we're left with is cosine squared theta plus sine squared theta, which hopefully we recognize as a Pythagorean identity. That's equal to 1, so r squared equals 25, so r equals 5. Really plus or minus 5. But in terms of the graph and how it would look, the radius will be 5. Alright, so if we want to convert these polar equations to rectangular form to sketch the graph, we can think about, we recognize that r sine theta is just y. So this is really just y equals 3. And so we have a horizontal line that looks like that. And this one is a little bit tricky. We have r equals 2 cosine theta. So we're going to talk later about how to graph this in polar form. So we'll get to the point where we recognize this and know exactly what shape it is. You may already remember that from pre-calculus. Just like we kind of recognize this as a circle, and we don't really need to do this work here. We just, oh, that's a circle centered at 0, 0, and radius is 5. We'll also do the same thing with these polar equations. But for now, let's turn this into rectangular form and see how it looks. I can do that. It might not be obvious why I'm doing this until after I do it, but I'm going to multiply both sides by r. And I get r squared equals 2r cosine theta. And now maybe we can see the reason for doing that is that this is just x. So r squared equals 2x. I know r squared is x squared plus y squared. So I'm going to put this in this form here. So I subtract the 2x over, I leave the x squared and the y squared here, but I rearranged them here. I'm going to complete the square on this section right here. So I have x squared minus 2x. I divide this term, this coefficient by 1 or by 2, and then square it. So I do get a 1. I have to add 1 to the other side. So I get x minus 1 squared plus y squared equals 1. So hopefully now I see this is a circle centered at 1, 0 with a radius of 1. So it'll look something like that. Right. This one here, part C, I have theta equals 2 pi over 3. And so all that means is, well, let's compare it. Let's compare it to this one here in rectangular form. This was y equals 3. So what does that mean to us? It means for any point on this line, the y coordinate has to be 3, but the x value can be anything. Right? So that's why we get this horizontal line. The y value is 3. The x value can be anything you want. You can move anywhere you want, left and right along that line. Well, here it says the angular measurement has to be 2 pi over 3, but your radius can be anything you want. So if I think about where 2 pi over 3 is, it's going to put me something like this here. Right, so I have 2 pi over 3. This is for a positive r. This would be r equals 0 at the origin. This would be for negative r. And the slope for this is about negative 1.7. So I may have drawn it a little bit too steep here. We can show that slope really by saying, okay, well, I can take the tangent of both sides. Tangent theta equals tangent of 2 pi over 3. And then I know tangent is y over x. And the tangent of 2 pi over 3 is negative root 3, which is approximately negative 1.7. So y over x, or I could put this in a linear form, y equals negative root 3 times x. All right, so again, we'll look at more of these graphing in polar form in the subsequent video, but for now we're going to take a little detour into some calculus. We're going to talk about the slope of the tangent line to a polar graph. All right, the slope of the tangent line is still dy dx, and dy dx, we're going to get that by taking dy d theta over dx d theta. All right, so when we do that, we need to recognize that x is r times cosine of theta and y is r times sine of theta. And when we take the derivative of, say, y with respect to theta, we have this product. They are both dependent upon theta. So we have to take, when we take the derivative, we have to use the product rule. All right, so when I take the derivative of y with respect to theta, I get, let's see, so I can say r cosine theta plus dr d theta sine theta over r times the derivative of cosine is negative, excuse me, negative sine theta plus dr d theta cosine theta. So if we rearrange that just a little bit, we end up with, I'm going to put the dr d thetas in front. It doesn't really matter. Plus r cosine theta. I have dr d theta, so they both start with dr d theta, both the numerator and denominator. This denominator here is now cosine. I'm going to have minus r sine theta. So this will tell me the slope of the tangent line, which is dy dx, when using polar form. All right, so let's look at an example of that. We want to find dy dx. Well, it's not and is the slope of the graph. We're finding the slope of the graph of the polar curve at the given value of theta. So we have theta equals pi over 6. So dy dx evaluated at theta equals pi over 6. Let's see. We have 2 cosine theta times sine of theta. So here's dr d theta times sine of theta, plus r is 3 plus 2 sine theta times cosine theta. And our denominator is dr d theta again, so 2 cosine theta times cosine theta now, minus r, which is 3 plus 2 sine theta times sine theta. All right, so at this point we have to just be real careful with our arithmetic and signs and evaluating our cosine and sine of pi over 6. So I have 2 times cosine of theta root 3 over 2. Sine of theta is 1/2 plus we have 3 plus 2 sine theta is 1/2 times cosine theta, root 3 over 2. And then our denominator is 2 times root 3 over 2. Again, that's just drd theta. Times now the cosine of pi over 6, root 3 over 2, minus 3 plus 2 times 1/2 times 1/2 sine of theta. So some arithmetic. Again, be careful with your arithmetic there. We'll get negative, oh, I'm sorry, you couldn't even see that. We'll get negative 5 over root 2. I apologize, when I was writing that down, it was kind of cut off, but that's what it looked like there.